4 of h plus h squared. Don't forget the negative sign in front of them. Simplify it as much as possible and use the substitution. You will end up having the first derivative, which is negative. And actually, what's happening up there is the slope of the line of intersection of the plan of y at 2 with the shape of your function, which is 9 minus x squared minus y squared. طيب واللي تحت هيبقى same way like, but just only on the other direction. Those the interpretation of what's happening. You are not required to draw the graphs here, just only to identify or to clarify the shape, to link it with geometry. But generally, those are the rules. Remember, I want you to remark that if I want to do a partial derivative within the dimension, so this is just only 2 dimension, okay? So if I have 3 dimension, if I have 3 variables, I can find the partial f, partial z, which is going to be exactly the same. The function will be a, b, and then c plus h, minus f of a, b, c, divided by h, exactly like those ones. So as a general case, if I am trying to get the f with respect to x to number k, the third coordinate, the function in this case will contain n variables. Then I will go to the k variable, adding h minus the value of the function divided by h, exactly like this guy. Okay, that's the generalization of the idea. Once more, he is asking you, using the definition of partial, once he asked or mentioned using the definition, I will have to do it using the law, the limit law. Okay? If he just asking you to find the first derivative, I can find it without the law, direct. And you will see problems just in a second. So once more, if I want to find the derivative of this function, I will have to do partial f, partial x at 0 and 0, which means I will use the limit of h tends to 0, f of 0 plus h and 0 minus f double 0 over h. All I have to do is to start substituting instead of each x by 0 plus h. So it's going to be 2, 0 plus h to the power of 2 times 0, then plus 0, minus h plus 0. So all the denominator will be negative h, divided by the denominator, which is h. Eliminate them together, it's going to be negative 1. So I don't want you to panic from the shape of the function. By the first talk to this function, you will imagine that it's going to be really very complicated. But once you start actual work with your pen, you will find it's very, very simple. In a similar manner, if I want to find partial f, partial y, exactly the same. So come with me. I will have 0 times 0 plus h plus 0 plus h minus 0. So it's just only h. What's more? So it's going to be a limit h divided by h, as you can see, and the result is equal to 1. So the first partial derivative exists and it's equal to negative 1. The first partial derivative with respect to y also exists and is equal to 1, as you can see. Okay, as I told you, this is Rn. In the case of functions of several variables or functions in vector valued functions, we will have the definition of the partial derivative, as I told you, partial f, partial x, or partial f, partial y. Here I'm going to use derivatives, but without the first principle. I want you to find the derivative. I will train you in finding the first derivative and the second derivative, but without using the definition. Direct substitution. You are telling me it's difficult. It's not that difficult. Okay, for this function, Mr. Muhammad, can you find me the first derivative with respect to x? Huh? Get f sub x. Yalla. Yes, you are correct. I will start differentiating considering x as a variable and y as a constant. Let's do it together. Differentiating x squared, which is going to be 2x times 1. Then plus, I will differentiate. X is the one who's going to be differentiated, which is going to be 3 times y squared. If this guy going to be differentiated, yes, and the derivative is equal to 0. That's the first derivative is equal to x. Hussein, can you get f sub y? Differentiate with respect to y, but consider x as a constant. Yes. This guy contains y. So the derivative of y is 1 times x squared. So it's x squared plus. Differentiate with respect to y, which is going to be 2y. So it's going to be 6x y. Differentiate with respect to y, so the derivative is going to be 4. So I'm using this way in partial derivatives if he didn't ask me to use the first definition or to use the definition. Are you with me? Okay. Like, exactly the same, he can ask you also for the second derivative. The second derivative in partial derivatives, it means I will differentiate the first derivative in order to get the second derivative. In this case, I can symbolize it this way, f double x, which means I will differentiate how many times? 2 times. In the 2 times, I'm differentiating with respect to x. Or can be written this way, partial 2f, I will differentiate f 2 times. With respect to x in the 2 times, which means I will differentiate the first derivative. Differentiate with respect to x. If this contains x, شايف x هنا؟ 0. If this contains x, derivative of x is equal to 1 times 2y. So it's going to be simply 2y.
2y.
طيب, can I differentiate with respect to y in 2 times? Yes. يبقى f double y. ها يلا. This is going to be 0.
1 لا
ليه مش لسه
هي فيها y؟
0
2y ماشي زي
ها دي هيدي لك 6x
6x
ايوه
وده في 0.
ايوه
بس انا كمان بيظهر عندي الميكسد ديريفاتيف. يعني ممكن يظهر عندي f x y, which means the first derivative with respect to x and the second derivative will be with y. So let's differentiate. That's the first derivative, okay? Differentiated not with respect to x, with respect to y. So differentiation with respect to y, Mr. Muhammad, it's gonna be 2 over x.
2x
Differentiate with respect to y, it's gonna be
6y
صح؟
لا ازاي
مش 2 في 3 ب 6 برضه؟
ماشي بس ازاي y
مش انت بتنزل باور to subtract 1 from the power? So 3y squared. صح؟ Okay, this is f of xy. طيب, can you get f of y and x? Which means I will differentiate the first derivative with respect to y, this guy. The second will be with respect to x. Let's do it together. Differentiate with respect to x. X squared can be differentiated with which is
2x
right. Differentiate with respect to x, which is gonna be
xy 6y
differentiate with respect to x 0. Remark that f of xy and f of y of x they are both equal to each other if the function is continuous and differentiable 2 times. ده difficult. بس يعني وقدر طلع اشعاع كويس. الآن as you can see, partial derivative with respect to x and y is treated once you are differentiating partial derivative with respect to x, consider y as a constant. If you are differentiating with respect to y, consider x is a constant, and so on. So this is the derivative of partial x for this guy, which is going to be simply 2 over xy 3y squared, exactly as we did. That's the derivative with respect to y, which is going to be x squared plus 6xy plus 4. That's the result, as you can see. Also, I can extend the first derivative and get the second derivative. This is this higher derivative. In this case, I will differentiate the first derivative with respect to x. The first derivative with respect to y, I have differentiated once more with respect to y. In this case, the first derivative with respect to x will be differentiated with respect to y. So once more, this is the second derivative. I took the first derivative, differentiating with respect to x, it's going to be 2y. If I want to find the second derivative with respect to y, it's going to be a 6 over x. If I want to get the mixed derivative, I will take this guy and then differentiate with respect to y. So it's going to be 2x plus 6y, as you can see. It's very simple. Once more, another problem. you will have e to the power of x sine y plus ln 1 plus x squared y. All the derivative laws are going to be applied with just only a small, okay, twist, which is you are choosing the variable for the derivative. If I'm differentiating with respect to x, y is going to be constant, and vice versa. So once more, Mr. Hussein, if I want to find the first derivative, how it's going to be with respect to x? So this is going to be e to the power of x times sine 1, then plus. Once you try to differentiate them, it's going to be 1 divided by 1 plus x squared y times the derivative of this part, which is 2xy. So,
Over x value.
that's the first derivative. Can you do the y? Can you do the y?
Yes.
Yeah, okay. So which part of this is going to be affected? The sine
Sine
y.
y.
It's going to be cosine y. So it's going to be e to the power of x cosine y. And then this guy will be 1 over 1 plus x squared y times x squared. Can we find the second derivative?
Yeah.
Yes. How many second derivative can you find? Differentiating 2 times with respect to x, 2 times with respect to y, and the second derivative also differentiating the first with respect to x, then with respect to y, which is called the mixed derivative. The mixed derivative. So once more, here we go. If I want to find f double x, all I have to do is differentiate this guy with respect to x. Okay?
Yes.
طبعا if I want to differentiate with respect to x second time, so it's an f double of x, it's gonna be e to the power of x, the derivative is e power x, times sine y. That's the first part. I'm going to the second part, but in this case, I have two functions divided in each other. What's the law? Do you remember the law?
No.
Huh? The denominator will be with the power of 2, so it's going to be 1 plus x squared y. Then I will differentiate the denominator, derivative with respect to x, is going to be 2y, times your denominator, which is 1 plus x squared y, minus, differentiate the denominator, but don't forget with respect to x, which is going to be 2 of an xy, times denominator, which is also 2 of an xy. Then simplify the shape. Simplify this function. معايا man? Okay, so once more, all I have to do is to just, this is going to be a 4 of an x squared y squared, and this is going to be plus 2 of an x squared y squared. So if I want to simplify just a little bit for you, it's going to be minus 4 of an x squared y squared, and this guy is going to be a 2 of a y, okay, then plus 2 of x squared y squared divided by 1 plus x squared y to the power of 2. Then I can eliminate these two guys together, so you will have 2y minus x squared y squared divided by 1 plus x squared y to the power of 2, as you can see. I can simplify it even more, taking y as a common from the denominator. You can do a lot of things. See? So, really, once more, I can find the first derivative as you will see. So once more, if I want to find, okay, f double x, I will start trying to differentiate e to the power of x. It's going to be exactly the same, ex sine y. Then I will take this part, which is going to be, I will try to make the denominator to the power of 2, differentiating denominator times the denominator, blah, blah, blah. Then taking the value of 2y, it's going to be 1 minus x squared y, divided by 1 plus x squared y to the power of 2 times ex sine y. In a similar manner, if I want to get fy, in this case, I will differentiate this guy. Okay? Can you differentiate it with respect to y once more?
Yes.
It's going to be negative e to the power of x sine y. Am I right?
Yes.
Can you differentiate this guy with respect to y? Any ideas, Mr. Hussein?
Yes.
It's going to be x
2x.
squared of 1 plus x squared y to the power of negative 1. If I want to find the second derivative, then it's going to be negative of an x squared of 1 plus x squared y to the power of negative 2. But don't forget times, okay, x squared. So actually, the result will be negative x to the power of 4 divided by 1 plus x squared y to the power of 2. That's the derivative. Do you understand, or did you understand the way we did in order to differentiate the second part? Instead of dealing with the law of the derivative of two functions, I've raised this denominator to be with power of -1. Then I made the derivative -1 times 1 plus x squared y to the power of -2 times x squared. Are you with me? Instead of going through the derivative using the law. Of course, in the direction of the x, I couldn't do this because I have x on the numerator and on the denominator. But in the direction of y, I have just only in the direction of the denominator, as you can see. So once more, this is f of y is going to be negative ex sine y. That's the derivative of x squared is going to be negative x4, as I told you exactly. And if I want to get the derivative, the next derivative, I will take the first derivative, then differentiate with respect to y. Or take the first derivative, which is with respect to y, and differentiate with respect to x, according to what's required from you. Okay? I want you to understand, because I suspect, or it's a very good question, which is going to be, if I give you a function and I've asked you about a little bit complicated mixed derivative, as you will see from the problems down the road. Also, here's, as I told you, differentiating with xy means I will differentiate with respect to y, the first derivative with respect to x. The order is really important, Mr. Hussein, because if you have a multiple choice problem, the order is important, okay? So once more, this is the derivative. Also, that's another problem, which is the root of x squared y squared. Can you bring me the derivative with respect to x, in this case? Any ideas how to bring it?
One.
Huh? So, f x, huh?
1 over 2x.
To the power of half. Differentiate. So it's going to be a half times x squared plus y squared to the power of -half. You are differentiating with respect to x. So I'm differentiating just only this guy, which is going to be 2 over x. In order to rewrite it once more, it's going to be half times 2, they will eliminate each other. It's an x divided by the root of x squared plus y squared. That's the first derivative in the direction of x. Can you do the direction of y? It's exactly the same. But instead of having 2x, I will have 2y for this problem. And also can be simplified in this manner. If I want to find the second derivatives, it will be exactly the same procedure as we saw previously in the previous problem. So once more, that's the first derivative, as I told you, that's the first derivative, and I can find f double x, f double y, f of xy if I want to, as you can see. Type, for this problem, he is giving you, consider the function f defined on the domain of xy belongs to r squared such that y is greater than 0. Why he told you about this? Why he's telling you about all of this? Because simply you have, if you remark, I have len y, am I right?
Yes.
And you can't use len without putting the condition that y should be greater than 0, صح? Okay. If I want to find partial f partial x, can you find it for me? Partial f partial x, it's really very simple. Huh? So f sub x is gonna be 3x squared y minus. I will differentiate with respect to x, which is gonna be negative over len y. This is differentiated x, considering y is a constant. Can you do partial f, partial y? I will start differentiating once more with respect to y. So differentiate x cubed y with respect to y is gonna be x cubed minus x over y. Derivative of len y is equal to 1 over y. Even now I have the derivative with respect to x or the derivative with respect to y. If I want to do further, I can do a second derivative as the previous problems or as usual. So once more, telling you about the partial derivatives, As I told you, this is going to be 3x squared y minus ln y. If I want to differentiate with respect to y, it's going to be x cubed minus x over y. Another problem, you will have e to the power of xy plus x sine x squared plus x of y. I can also differentiate with respect to x or with respect to y. If I'm differentiating with respect to x, I will consider y as a constant and vice versa. So if I want to differentiate with respect to x, this is gonna be direct. I can write it directly. بص كده يا حسين. If I want to get f sub x, I will differentiate this guy, which is gonna be e to the power of xy times y, because differentiating x will be 1 times y. Let's do it together, Mr. Muhammad, for the other part. How many functions are in x? I'll differentiate the first times the second, then differentiation of the second times the first. Differentiate x, which is gonna be 1. So the result will be sine of an x squared plus x and y. Then plus, the first part is x times derivative of a sine, which is gonna be a cosine of an x squared plus y squared, but don't forget times the derivative of the angle, which is gonna be a 2 of an x. Rewrite it all over again and gather the various terms all together. Then you will have this part, it's gonna be plus 2 of an x squared cosine of an x squared plus y squared. Also, I can do this derivative with respect to y. But in this case, the first term will be exactly the same with a slight difference. Instead of having y, it's gonna be x. So if I want to get f sub y, it's gonna be e to the power of x, y. But in this case, I'm going to make the derivative with respect to y. So it's times x. Then plus, I will differentiate. X is a constant, so it will remain. Now I'm coming to the point of sine. I will differentiate sine. So it's gonna be x times cosine of an x squared plus xy times, I will differentiate with respect to y, which is x. So that's the second derivative. I'm sorry, the first derivative with respect to x. It's really very simple, but you will have to more than once to solve it in order to be able to write it as smooth as you can see. So please, all of these problems, you will have to do them once more, just with a pen and a pencil, and start reviewing or start to solve these problems once more. That's the first derivative, and that's the second derivative. As I told you, x times e to the power of xy plus x squared cosine x squared plus x over y. طيب, for this function also another problem. He wants you to determine partial f partial x, partial f partial y, which is direct. The derivative will be direct. If I want to do the derivative with respect to x, this is going to be 1, that's 0, that's going to be 6xy. If I want to do the derivative with respect to y, this is going to be 2y, this is going to be plus 3x squared. Those are the derivatives. That's the first one. That's the second, as I told you, 2y plus 3x squared. Here you use the addition, the constant taken outside the derivative sign, and the deviation for a constant equal to 0. Similar manner for x times sine 2xy plus exy. If I want to find the first derivative with respect to x, with respect to y, it will be really very simple. I will leave it for you. It's a very simple problem. For this problem, no, I will have to stop a little bit. Why I have to stop a little bit? Because you have function which is defined on more than one domain, not just only this, but also you have an absolute value which is absolute of y. In this case, I will need to use the definition. Let's do it together. So once more, if I want to find the derivative with respect to x at the origin, I will use the definition, which is limit 0 plus h at 0 minus f double 0 over h. I will make the substitutions. Here is 0 plus h and 0. Remark, if y is equal to 0, the value of function is equal to 0. You don't have to do anything. So this is 0, minus 0. So it's gonna be equal to 0, see? From the second part, the value is equal to 0 directly. Exactly in the similar manner, if I want to find the derivative but in the y direction, it's going to be 0 plus h. But remark here, in this case, I will use the first part. ليه يا حسين استخدم الفيرست part؟ لأنه in the case of y doesn't equal to 0. Here y 0 plus h. So I will use the first part. That's the first part. Therefore 0 plus h, which is h squared over the absolute of h over h. One of these h's will eat the denominator, then you will have absolute h. This function at the origin doesn't have a derivative. Why it doesn't have a derivative? Because at this point, the limit, if you are talking about limit h tends to 0, right? You will have h over h, which is 1. If you have limit h tends to 0 from the left, then it's going to be h over minus h, which is going to come up to a negative 1. And they are not equal to each other. So once more, it's not differentiable at this point. So the first derivative with respect to x already exists, it's equal to 0. The second derivative with respect to y doesn't exist. Are you with me?
Yes.
Okay, so once more, here is the function, as I told you, where 0 is positive, 0 is negative, the values are different than each other, so the limit doesn't exist, as you can see. So the first derivative with respect to x exists, or the second doesn't exist. Now I want to talk with you about the gradient vector and the Jacobian matrix. The gradient vector, actually, it gives you the direction of the perpendicular direction at certain point. That's the gradient vector. The gradient vector is really very simple. All you have to do is to find the partial derivatives of a certain function with respect to its variables. If I tell you once more, I would try to find the partial derivatives of the function with respect to its variables. The definition, it's stated in front of you. Let f such that d, it's a subset from Rn into R, be a real function with variables x1 up to xn, where a belongs to the interior of the domain. The gradient vector in this case will be differentiating f with respect to x1 at a, differentiating f with respect to x2 at a, and so on. That's the gradient vector. Okay. When computing the partial derivatives of a function, the application of gradient vector is enormous. You can use it in plenty of ways. That's the definition of the gradient vector, as I told you. طيب, I want to evaluate the gradient vector for this function. ثانية وممكن دي stop شوية. Okay, عايز اوجد the gradient vector for this function. Any ideas, Mr. Muhammad? يبقى gradient vector, yes, you are right, the gradient vector for this function f is simply, it's gonna be partial f, how many variables? 3. Partial f, partial x, and partial f, partial y, partial f, partial z. Let's do it together. So it's gonna be the gradient vector of f. Open your matrix or whatever. You can write it in matrix form or in the coordinate form. If it is in matrix form, differentiate with respect to x. X is going to be equal to 1. So it's going to be y times len of 1 over z. Type differentiate with respect to y. It's going to be x times len 1 over z. Type differentiate with respect to x. With respect to z. Before going to the derivative with respect to z, let's look to this guy. I can rewrite it this way. xy times len z to the power of negative 1. Can I?
Yes.
Okay. And one of the probabilities of the logarithmic function that the power can be taken outside, which is going to be negative xy len z. And the derivative in this case, guys, it's going to be negative xy over z. He wants you to evaluate the derivative, Mr. Hussein, wants to evaluate the gradient vector, but at the point 1, 1, 1. So after getting the gradient vector, I will make a substitution. Len 1 is going to be 0. Len 1 is going to be 0. So simply it's going to be 0 and 0 and 1 times 1 over 1. So it's going to be negative 1. That's the gradient vector at the point 1, 1, 1. So as I told you, it's really very simple to find the gradient vector, okay, of this function. بص partial f partial x partial f partial y partial f partial z at the triple one. That's the derivative y times ln 1 over z, x times ln 1 over z, minus xy over z. Then substitute instead of x, y, and z, you will have 0, 0, and negative 1 seconds. Okay? I will give you a short break for 5 minutes or so, then we will continue. We will have to finish
Why?
this. We will have to finish this part today, inshallah.
We made a big,
Thank you very much.
big
Thank you.
progress. We made a big progress.